Hello, this is Unit 4, Module 2, Session 5. The name of this home connection is Thinking About Subtraction. Name and number, please. Let's begin. We're going to look at each subtraction problem below. We've got an A, B, C. Think about which strategy makes most sense for each problem and solve each problem. You are allowed to choose the strategy you want, but I will encourage you, if you're going to use the standard algorithm, to rewrite it so you have more space, because when you have to borrow, it's hard to squeeze in the ones. Okay, so it says 4,875 minus 4,859. As I look at this, I think to myself, well, I've got more on the floor, so I'm going to have to go next door. I have to borrow at least once. Maybe that won't be so bad, so maybe I'll use the standard algorithm. And I do space these numbers out, right? These are really tight. I space these out. 4,859. You're going to see why I make these nice and spacey. I put a little space in between each one. I've got more on the floor, so I go next door. I can't subtract 9 from 5. So I'm going to go to this 7, and I'm going to borrow a 1 from it. And then this 7 becomes a 6. And maybe I'll write that in black so it's a little bit easier to see. Okay? So now I'm subtracting 15 and 9, right? 15 minus 9 is 6. 6 minus 5 is 1. And 48 minus 48 is 0. So I'm not going to worry about that at all. I could write 0, 0, but what is this number? It's just 16. There's no reason to. It says, why did you use this strategy? For me, it was maybe faster, I think, than maybe doing a number line. Although maybe the number line would be faster for you. Only borrow once. Okay, so that's what I'm going to say. Those are my reasons why. If you chose a number line, maybe it's because you wanted to go from, you thought maybe from, I don't want to spend too much time on this, but we were starting at 4859 and we're trying to get to 4875, right? If I was trying to figure out this distance here, maybe I could go, well, if I do plus 1, I'd be at 4,860. And then to get to 75, I'd have to go plus 15. Okay? 1 and 15 is 16. Right? So it's the same answer. So a number line would work. You could also do maybe some give and take if you wanted to, or give, take, take. It's up to you. But make sure that strategy ends up with the number 16. Okay? 1,685 minus 1,685. I bet you know what that answer is just in your head, but you have to say what strategy you're going to use. Okay, if the answer is 0, how did you get there? Did you use a number line? Did you use the standard algorithm? Did you use give? Did you use take? And why did you do it? Even if you did this in your head, you used a strategy. Which one did you use? And why? I'm going to let you write that down on your own. Ooh, okay, I'm going to give you a suggestion for this one. You don't have to do it, but when I look at 699 minus 424, when I'm thinking of which strategy to use, I check to see if the bottom number is smaller than the top number. 4 is smaller than 9, 2 is smaller than 9, 4 is smaller than 6. When you do the standard algorithm in this kind of situation, you don't have to borrow, do you? 9 minus 4 is 5. 9 minus 2, 7. 6 minus 4, 2. No borrowing. There's my answer. So why did I use that strategy? So I used the standard algorithm. I'm just abbreviating to save time. Why? Very fast. No borrowing. Okay? You solve it however you want. Pause this video if you want to work on those. Okay? Oh my goodness, we've done this a few times, and I am not going to necessarily give you the answer for the last two, but I'll help you with the first one. Okay? I have a larger number minus a smaller number, a larger number minus a smaller number. Okay? So what we're going to do is I'm going to say, how does 498 become 500? Well, Mr. Keogh, you have to add 2. Well, we know that when we're subtracting and we're trying to balance the equations, we have to use give or take. Well, since we gave 2 to the first number, we're also going to give 2 to the second number. 323 plus 2 is 325. Done. So you have to make sure the first number and the second number have the same operation done to it. In this case, it's add 2. Okay? If you want to try this way, you're going to maybe go backwards, and you're going to say, well, you don't necessarily have to, but I like to make my arrows go to the side that has the blank. Right? So here's my first number, here's my first number. I'm going to say, how did 70 become 68? And whatever you do here, you have to do to this number. Then 55 becomes something else. Okay? I'm not going to give you the answer, but to get 70 into 68, you have to subtract 2. So you're going to subtract 2. And I'm going to let you finish it from there. Okay? Pause it to solve it, and then move on. On our last one, same thing. First number, second number, second number. So I'm going to say, how does 498 become 495? And whatever you do to it, you also have to do to this number. So if this is a give or a take, all right, you're going to decide. Like I mention it all the time, but pause this video. In class, you can't pause me, because I still go unless you ask a question. But when I'm on YouTube, you can pause me whenever you want to, so you can take time to solve. Number 3 says, Jenny got a box of 15 stickers for her birthday. Use this information as you solve each problem below. Use numbers, labeled sketches, or words to show your thinking. Jenny used 5 stickers on a thank you card. What fraction of the box did she use? So you have 15 stickers in the box, and she used 5 of them. Yeah, 15 minus 5 is 10. We know how many stickers she has left, but that's not what it's asking. So you might be tempted to just jump in and do some subtraction. Please do not. Please do not. It says, what fraction of the box did she use? So how many pieces are in the box? 15. Okay, that's the bottom of my fraction. How many stickers did she use? 5 out of the 15. So when we're thinking about fractions, when we're talking about numbers of items, the bottom number would be the total number of pieces that came in the box. The top number, in this case, is how many she used. She used 5 stickers, 5 out of the 15. Okay? It says Jenny gave her brother 4 stickers. What fraction does she have left? Well, she started with 15. Okay? She already used 5, so she has 10. Then she gave her brother 4 of them. How many does she have left? 6. But it says, what fraction of the box does she have left? So 6 is not your answer, but it will help you get the answer. Because once again, we're going to do a fraction. 6 out of 15. So the fraction that she has left is 6/15. Okay? After she gave some stickers to her brother, Jenny's dog ate 3 of her stickers. Oh my goodness. So she had 6. Her dog ate 3 of them. She only has 3 stickers left. But it says, what fraction, where am I? Now what fraction does Jenny have left of her original box of 15? How many out of 15? 3 out of 15. So she has 3/15 left. Now, here's a tricky question. What fraction of the stickers went to Jenny's brother and, that would be a plus, her dog? This problem you're going to have to do on your own, keeping in mind that we're going to come up with a fraction over 15, but I need you to add how many she gave to her brother and how many the dog ate, and that will go there. Pause this video, please, and finish that problem. Number 5 says, the 3rd grade gymnastics team has 279 points. In order to place in the top 3 teams, they'll need to score need a score of 425 or more. How many more points do they need to earn in order to rank in the top 3? So they need 425 or more. They're already at 279. So if I had this number line, something like this, they have 279 points. Once they get to 425, they're good. They'll be in the top 3. We're trying to figure out how many more they need to get to this number. And you can use any strategy you want, but since I already have a number line, stick with me. Okay, we could use standard algorithm. We could do 425 minus 279. But just for giggles, let's try it this way. I'm going to get to 280 by adding 1. Okay? Now I'm going to try to get to 400. Or excuse me. Excuse me. I'm going to try to get to 300. Okay? How do I get to 300? By adding 20. Now I'm at 300. How do I get to 400? Well, I'm going to add 100. And then how do I get to 25? By adding 25. Just to make sure that you're following me, stay with me. To get from 279 to 280, I add 1. Now to get to an even 300, I'm going to add 20. To get to 400, I have to add 100. 300 plus 100 is 400. And to get to 425, I'm going to add 25. If I combine all of these numbers, I will have the answer. So if I do 100, I'm going to put these in order, plus 25, plus 20, plus 1, from biggest to smallest, that will be my answer. So I have 125, 145, plus 1, 146. If I did the standard algorithm, 425 minus 279, I should get the same answer. Let's try it real quick. More on the floor, I'm going to go next door. So that means I'm going to borrow 1 from this 2 to get a 15. Okay? 15 minus 9 is 6. Uh-oh, there's more on the floor again. I'm going to go next door. So this 4 is going to become a 3, and I borrow a 1. So I have 11. 11 minus 7 is 4. 3 minus 2 is 1. So I do get the same answer. You're allowed to use whatever strategy you want. Final question. Brendan needs to mail a 12-page letter to his friend in Texas. It cost $1.38 to mail all 12 sheets together. A 6-page letter cost 68 cents to mail. A 4-page letter cost 45 cents to mail. Envelopes cost 3 cents each. What is the least expensive way to mail his 12 pages? So, if we're going to mail in one envelope, okay, what did it say? All 12 sheets is $1.38. Plus the envelope, 3 cents. Okay? Let's say I wanted to do it in 2 envelopes. Oops, envelopes. Sorry about that. It says, so that would be a 6-page letter and a 6-page letter, because 6 plus 6 is 12. That's going to cost 68 cents, plus another 68 cents, plus 3 cents for each envelope. So that's 6 cents. Okay? Let's say I was going to mail it in 3 envelopes. So I'm going to have to do 4-page letters. That's 45 cents each. So that would be 0.45 plus 0.45 plus 0.45 plus my 3 envelopes. That's 3 cents each, so that's 9 cents. Those are the 3 ways that I can mail these 12 letters. Keeping in mind that I have to make sure I have enough envelopes. 1 envelope, 3 cents. 2 envelopes, 6 cents. 3 envelopes, 9 cents. But we have to figure out, are any of these cheaper than the others? $1.38 plus plus 3 cents is what? I'm going to write my answer over here. $1.41. Okay. If I add up all of this, 120, 136, $1.36 is $1.42. I'm just doing this in my head, so if you work this out and your answer is different, make sure you let me know, or let your teacher know that I gave you a wrong answer. And then 45 cents plus 45 cents is 90 cents, plus another 45 cents is $1.35. $1.35 plus 9 cents is $1.44. I'm pretty sure. I really should stack and add. We need to know what is the cheapest way. What do you think? Probably one envelope. $1.41 is the cheapest. Although these aren't bad, right? Okay. If you have questions or if you come up with different answers, make sure you let somebody know so that I can fix this video. I really shouldn't be doing mental math, but I'm trying to make sure these videos don't last too long. Ask a math wizard or a teacher if you have questions, please. Check you guys later.